Ignition sequence start. All engines are running. We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking,
One small step for man,
and left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap. We're building the next chapter of American exploration, returning to the moon to stay, so we can go beyond to Mars, to expand what's possible and further our understanding. The architecture for these missions is already taking shape. We will go with new systems, bold designs, and a sustainable mission. You can hear it, taste it, touch it. We are going. We are training, testing, pressing our pioneering spirit into every component, defining our resolve with every line of code, and securing our success with every welcomed partnership. This is not hypothetical. This is not about flags and footprints. This is about sustainable science and feeding forward the advance of the human spirit. Because we are the pioneers, the star sailors, the thinkers, the visionaries, the doers. And because we stand on the shoulders of giants to go farther than humanity has ever been, we will add our names to the rolls of the greatest adventurers in history. Every day, every mission, we advance this goal. We are NASA. And after 60 years, we're just getting started.
Choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
T-minus 60 seconds and counting. We are go for Apollo 7 at this time.
and from the crew of Apollo 8, we close with good night, good luck, a Merry Christmas, and God bless all of you on the good Earth.
We have ignition sequence start. Engines on. 5, 4, 3, 2.
Listen, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind. We leave as we came, and God willing, as we shall return, with peace and in hope for all mankind. We're on our way, Houston.
From 1969 to 1972, we had, a total of 6 moon landings. 12 humans walked on the surface of the moon. We have elevated the human condition. We have improved human lives. We have raised the standard of living for every person on Earth because of space exploration. We're going to go back to the moon, and we're going to take what we learned there, and we're going to go to Mars.
We set sail on this new sea because there is new knowledge to be gained. But why, some say, the moon?
But why, some say, the moon?
But why, some say, the moon?
Why choose this as our goal? And they may well ask, why climb the highest mountain?
Why, 35 years ago, fly the Atlantic?
Why does rice play Texas?
We choose to go to the moon.
We choose to go to the moon.
We choose to go to the moon.
We choose to go to the moon in this decade and do the other things.
Not because they are easy,
but because they are hard.
because that goal will serve to organize and measure the best of our energies and skills.
Because that challenge is one we are willing to accept,
one we are unwilling to postpone,
and one which we intend to win.
And one which we intend to win.
And one we intend to win.
Good morning. You are looking live at Site 31 at the Baikonur Cosmodrome in Kazakhstan, where a Soyuz-2.1A booster rocket stands fully fueled, ready to launch just over 16 minutes from now to send an unpiloted Progress resupply ship, a Russian resupply cargo craft, to the International Space Station on a fast-track to-orbit, 3-hour express delivery run to send more than 3.5 tons of food, fuel, and supplies to the crew members on board the International Space Station. The flight, as it always is for a Progress or a Soyuz vehicle, will be controlled after the Progress reaches its preliminary orbit by flight controllers at the Russian Mission Control Center in the town of Korolyov on the outskirts of Moscow. The flight control team has been on console throughout the course of the morning hours, monitoring all of the preparations at the launch site in the Central Asian desert. Here in Mission Control in Houston in the International Space Station Flight Control Room, the Orbit 1 team of flight controllers has been on console throughout the overnight hours, led by Flight Director Greg Whitney. He and his team of flight controllers working in tandem with the Russian flight control team down in Baikonur and outside of Moscow. Whitney in the dark sweater, joined on console in the burnt orange shirt by spacecraft communicator Travis Fitzgerald, who is talking to the crew on board the International Space Station. At the bottom of your screen is Flight Director Rick Henfling, who will be the flight director for the docking phase of the Progress's automated approach and link up to the Pirs docking compartment later this morning after its two-orbit trek to the International Outpost. It's a beautiful day down in Baikonur, mostly sunny skies, temperatures about 56 degrees Fahrenheit. The Soyuz-2.1A booster was fully fueled several hours ago. All of the propellants being replenished at this hour as we are in the final minutes of the countdown that will lead to a launch at 6:01 and 34 seconds a.m. Central Time, 4:01 and 34 seconds p.m. at the launch site in Baikonur. The Progress is carrying 3,375 pounds of propellant to the station, 104 pounds of oxygen and air, 926 pounds of water, and 3,117 pounds of spare parts and other supplies for the crew on board the International Space Station, including some of the components that will be used next Monday during the next spacewalk to be taken by the Expedition 59 crew members, David St. Jacques and Anne McLean, to set up some structural support trunnion devices on the outside of the Columbus module of the International Space Station. That's all loaded in this unpiloted Progress craft. At the time of launch, the International Space Station will be flying over southwestern Kazakhstan, 316 miles behind the Progress as it begins its climb off the launch pad. 38 seconds after Progress launches, the space station will pass directly over the Baikonur Cosmodrome and then leapfrog past the Progress en route to being in a position in front of the Progress, where at the 8-minute 46-second mark after launch, when the Progress is released from the third stage of the Soyuz-2.1A booster and moves into its preliminary orbit, the ISS will be 1,049 miles ahead of the Progress vehicle as the Progress begins a series of pre-programmed engine firings to increase its altitude and fine-tune its path to the International Space Station for the automated docking to the Pirs docking compartment that is scheduled at 9:25 a.m. Central Time this morning. This is the second two-orbit rendezvous that the Russian flight control team will be executing, the first coming last July with the 70 Progress vehicle. The trajectory of this particular flight results in a very narrow phase angle at launch. That's the corridor. The way orbital mechanics works, the launch time for any vehicle to reach the International Space Station is selected at the moment that the Earth's rotation carries the launch site into the plane or corridor of the orbit of the International Space Station, which is inclined 51.6 degrees to either side of the equator. In this case, to reach the space station in just 2 orbits. The launch will occur with a narrow phase angle at about 2.4 degrees, and at orbital insertion, 8 minutes and 46 seconds after launch, that phase angle will have expanded, but still narrow at 14.4 degrees. Think of it as driving your car on an on-ramp to a freeway and hitting the correct lane with just seconds to spare so that you're in the right direction of travel. That's the way the phase angle and the launch time are calculated to bring the Progress to a 2-orbit, 3-hour rendezvous and a link up to the International Space Station for an expedited delivery of its 3.7 tons of cargo. We're about 10 minutes, 45 seconds away from launch. All of the preparations have gone very smoothly. Earlier this week, on Monday, the Progress was transported to the launch pad from its processing hangar just about a quarter of a mile away at Site 31. The familiar railroad car hauling the Progress vehicle and then hydraulically lifting the vehicle to its vertical position on the launch pad. This all occurring this past Monday at Site 31 at the Baikonur Cosmodrome in Kazakhstan. On board the International Space Station, the Expedition 59 crew busy with a variety of activities. They'll take a few moments out to watch the launch that is being uplinked to them by flight controllers here in Mission Control in Houston. From left to right, Canadian Space Agency astronaut David St. Jacques, NASA's Anne McClain, the commander of Expedition 59 from Roscosmos, cosmonaut Oleg Kononenko. Next to him, Alexei Ovchinin, and then on the right, NASA astronauts Nick Hague and Christina Cook. Earlier this morning, St. Jacques and McClain were in the Quest airlock of the International Space Station as St. Jacques went through a verification fit of the spacesuit that he will wear for the first spacewalk of his career this coming Monday, the third in the current series of spacewalks to perform maintenance and upgrades to hardware on the International Space Station. But the first order of business today is the launch of the Progress vehicle. This is the first of 3 cargo ships to be launched over the next couple of weeks to deliver more than 10 tons of supplies to the International Space Station. Coming up on April 17th at the Wallops Flight Facility in Virginia, Northrop Grumman's Antares rocket will be launched to send the SS Roger Chaffee, the Cygnus cargo craft, to the International Space Station for a capture and berthing on April 19th, followed shortly thereafter, about a week or so later, by the launch of the next SpaceX Dragon cargo ship to the International Space Station. So the chain of international and multinational supply craft to the International Space Station continues, with the latest series beginning less than 8.5 minutes from now with the launch of the Progress aboard the Soyuz-2.1A booster from the Baikonur Cosmodrome. At this hour, the International Space Station is flying from southwest to northeast across the Saudi Peninsula. Again, the space station will be slightly behind the Soyuz booster in the Progress as it begins its climb to orbit, with launch just under 7 minutes from now. But of course, the space station will leapfrog past the Progress during its climb to orbit. The Soyuz-2.1A booster, a 3-stage rocket. The first stage with its liquid fuel engines and strap-on boosters will burn for 1 minute 58 seconds before the strap-on boosters are jettisoned and the first stage separates. That'll be followed about a minute later by the jettisoning of the launch shroud that you see, that conical dark section at the very top of the Soyuz booster that envelops the Progress resupply ship. The second stage engine burns for 2 minutes and 39 seconds to continue propelling of the Progress toward its preliminary orbit. The second stage separation will occur at the 4 minute 47 second mark, followed by the ignition of the third stage engine, which will burn for an additional 4 minutes and 9 seconds until it is shut down at 8 minutes and 46 seconds after launch, followed just seconds later by the Progress's separation from the third stage and the initiation of the deployment of its solar arrays and navigational antennas. At the blockhouse in Baikonur, launch controllers reporting a purge of nitrogen for the first stage. That first stage will be pressurized at about the 2 minute 45 second mark before launch. The pressurization of the first stage fuel tanks will optimize the flow of fuel, helping the structural support of the rocket as it sits on the launch pad. Again, this is launch site 31 at the Baikonur Cosmodrome in Kazakhstan. The Progress ready to roll, ready to begin its two-orbit trek to the International Space Station. Just 4 minutes until launch. Coming up on the 3 minute mark until launch, the International Space Station about to fly over the Caspian Sea. There are two structural umbilicals buttressed up against the side of the Soyuz-2.1A booster. The first will retract at about the 40-second mark before launch. The second at about the 12-second mark. It is the second umbilical's retraction that will initiate the auto sequence start for engine ignition and liftoff. Coming up on the 2 minute mark until launch. Pressurization of the fuel tanks complete. The ground propellant feed about to be terminated. Everything is go for launch, coming up on the 1 minute mark. There is the retraction of the second of the two umbilicals as we stand by for main engine start. Engine start command issued. Engines up to flight speed. And liftoff. Liftoff of the 72nd Progress resupply vehicle. Destination station 2 orbits from now. Pitch, roll, and yaw program are in. 38 seconds into the flight, the International Space Station now flying directly over the Baikonur Cosmodrome. One minute, 15 seconds into the flight, the Soyuz booster passing through maximum dynamic pressure. Everything operating nominally. Good structural parameters reported from the launch engineers in Baikonur. Roll, pitch, all nominal as we stand by for first stage separation. First stage separation is confirmed. The vehicle is stable. Second stage engine up and burning. This will be about 2 minutes and 39 seconds of second stage performance. Everything so far so good. Good roll, pitch, and yaw. Second stage engine reported to be operating normally. Everything looking good. The Soyuz booster traveling more than 5,000 miles an hour, 49 miles in altitude already, 72 miles downrange from the Baikonur Cosmodrome, just over 3 minutes into the flight. Shroud jettison has been confirmed. All of the vehicle parameters reported to be normal. About 1 minute, 11 seconds left in second stage performance. At the 4-minute mark, everything is reported to be operating normally. The Soyuz booster in the Progress traveling more than 7,300 miles an hour, 81 miles in altitude, 190 miles downrange from the Baikonur Cosmodrome. Coming up on the 4.5-minute mark into the flight. Standing by now for second stage shutdown and second stage separation. Second stage separation is confirmed. Third stage engine up and running. Everything looking good at the 5-minute mark into the flight. About 3 minutes and 45 seconds of powered flight remaining. All structural parameters still nominal according to the launch engineers at the blockhouse in Baikonur at the 5.5-minute mark into the flight. Third stage engine burning as advertised. The third stage of the Soyuz-2.1A and the Progress now traveling 11,000 miles an hour, 115 miles in altitude, 472 miles downrange from the Baikonur Cosmodrome. Roll, pitch, and yaw program, all nominal. Good structural parameters being reported at the 6-minute, 15-second mark into the flight. 2.5 minutes of powered flight remaining. Six minutes, 45 seconds into the flight, everything continuing to perform as advertised as the Progress heads toward its preliminary orbit, with the space station awaiting its arrival just over 3 hours from now. Roll, pitch, and yaw nominal. Third stage engine burning as advertised. Everything looking good. Seven and a half minutes into the flight. The Soyuz and the Progress now traveling 14,000 miles an hour, 124 miles in altitude. The trajectory flattening out. About 1 minute of powered flight remaining. Good third stage performance. Some 30 seconds of powered flight remaining. We're at the 8.5 minute mark since the Progress lifted off. Standing by for third stage shutdown and spacecraft separation. Third stage shutdown confirmed. Spacecraft separation confirmed. And the report from Mission Control in Korolyov is that the solar arrays and the navigational antennas, all of the appendages have deployed as advertised. So this was a perfect launch, right on time, a flawless ascent, uneventful, as the Progress now has reached its preliminary orbit for a 2-orbit trek to reach the International Space Station. Just to recap, liftoff occurred on time at 6:01 and 34 seconds a.m. Central Time, which was 4:01 and 34 seconds p.m. in Baikonur at the launch site. The Soyuz-2.1A booster lifted off from launch site 31 in Baikonur, climbed out to the northeast, and began its journey to catch up to the International Space Station. That will culminate with an automated docking to the Pirs docking compartment on the Earth-facing side of the Russian segment of the outpost, coming up in about 3 hours or so at 9:25 a.m. Central Time, 10:25 a.m. Eastern Time. And with the television camera having been deployed and activated on the Progress-72 cargo ship, this first view from that camera with the engineering overlay, you'll be seeing more of these views in a couple of hours or so when we're back on the air for rendezvous and docking of the Progress to the Pirs docking compartment. But this is the first test of the telemetry stream from the Progress-72 back to the control center in Korolyov, where the Russian flight controllers now begin their work to follow the journey of the Progress-72 to reach the International Space Station. The first rendezvous burns will begin in about 28 minutes, the so-called DV1 or Delta Velocity 1 burn, using the main engine on the Progress, about a 90-second engine firing. That will raise the altitude of the Progress to match that of the International Space Station and to fine-tune its path to the International Space Station. That'll be followed around the top of the hour with the Russian flight controllers giving a go, no-go for the 2-orbit rendezvous. But so far, so good, with all of the elements on the Progress-72 in good shape, as it made a flawless trek off the launch pad in Baikonur toward its preliminary orbit, and now begins a 3-hour journey to reach the Pirs docking compartment and the delivery of more than 3.5 tons of food, fuel, and supplies. So that'll wrap up our launch coverage for Progress-72. One programming note, we'll be back on the air in 2.5 hours at 8:45 a.m. Central Time, 9:45 a.m. Eastern Time with our rendezvous and docking coverage. Docking again is scheduled at 9:25 a.m. Central, 10:25 a.m. Eastern Time. So we'll see you back here in a couple of hours. For now, we'll wrap it up. This is Mission Control Houston.
Hey, you're watching NASA TV, on the air and online every day, on this planet and beyond.
Ignition sequence start.
Good morning. Welcome to Mission Control Houston and the International Space Station Flight Control Room. This is where there's always a team of specialists on duty 24/7 when the station is in communications range to manage the mission of the station and its human crew, who now numbers 6 once again. Expedition 59 began yesterday when 3 new crew members arrived to join Commander Oleg Kononenko and flight engineers Anne McLean and David St. Jacques to do scientific research and spacewalks and more during the next 3 months.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Isidro Reyna. This week, 3 new crew members launched at the International Space Station. The new crew is adjusting to life on station after a successful launch and docking of their Soyuz spacecraft. The Soyuz spacecraft carrying Nick Hague and Christina Cook of NASA and Alexei Ovchinin of Roscosmos launched on Thursday, March 14th from the Baikonur Cosmodrome in Kazakhstan. Hague, Cook, and Ovchinin docked to the space station's Rosviet module after a 4-orbit, 6-hour journey and opened the hatch about 2 hours later. The arrival of Hague, Cook, and Ovchinin restores the station's crew complement to 6. They've joined Anne McLean of NASA, David St. Jacques of the Canadian Space Agency, and Expedition 59 Commander Oleg Kononenko of Roscosmos. The crew members will spend more than 6 months conducting about 250 science investigations in fields such as biology, earth science, human research, physical sciences, and technology development. This week's question comes from Henning, who wants to know why spacesuits have such low pressure. Well, that's a great question, Henning. It has to do with mobility. The space station is pressurized to 14.7 pounds per square inch, pretty much what you'd find here on Earth. It's comfortable, and you can keep the space station air in a mixed nitrogen-oxygen environment, again, very similar to Earth. U.S. spacesuits, though, are pressurized closer to 4.3 pounds per square inch. Astronauts have to spend a lot of time free-breathing and purging nitrogen from their bloodstream to maintain a 100% oxygen environment. But the low pressure allows the suit to be a lot more flexible, which is much needed when you have to spend 6.5 hours flexing rigid space gloves to do work on the outside of the space station. Keep sending in your questions using the hashtag #SpaceToGround. We'll see you next week.
Now, let me ask you, do you think it's been a really busy last 5 months for you? It will take a minute to think about what that time has been like for new International Space Station flight engineer Nick Hague. He had expected to arrive on orbit back in October, but the Soyuz launch abort set him and Alexei Ovchinin on a new course to get to the space station.
On October 11th, 2018, after more than 2 years of preparation, NASA's Nick Hague and Alexei Ovchinin of Roscosmos suited up for their flight to the International Space Station. The Soyuz rocket lifted off from the Baikonur Cosmodrome in Kazakhstan, and the climb to orbit went perfectly for the first 2 minutes, until one of the Soyuz rocket's strap-on boosters failed to properly separate from the rocket's first stage, triggering a launch abort. The spacecraft carrying Hague and Ovchinin pulled free from the first stage and flew on a ballistic trajectory that touched the edge of space before floating under parachutes to a safe landing on the steppe of Kazakhstan. A short time later, Hague and Ovchinin were picked up by Russian search and recovery teams, then flown back to Baikonur for a reunion with their families, and Greetings from NASA Administrator Jim Bridenstine and the head of Roscosmos, Dmitry Rogozin, who promised the men they would be assigned to another Soyuz flight to the station. In December, the station partnership announced that Haig and Ovchinin would fly in March 2019, this time joined by NASA's Christina Cook to become a part of expeditions 59 and 60. A few weeks ago, Haig, Cook, and Ovchinin wrapped up their work at the Gagarin Cosmonaut Training Center in Star City, Russia, and passed their final exams, then left for Baikonur and final preparations for their launch on a 6.5-month mission to the International Space Station.
Now, you already know that this is Nick Haig's second spaceflight. You also probably know he's a colonel in the U.S. Air Force and an astronautical engineer by training. But that just scratches the surface. Here's the inside story on his favorite science fiction, his food craves, and the physical training that got him in shape to squeeze into a Soyuz spacecraft.
So we're an Air Force family. Something you may not know about us. I met my wife at the Air Force Academy back in 1996 when we were in the same squadron. I was from Kansas. She was from New York City. We never would have crossed paths hadn't been for the Air Force Academy. So a question I get all the time is, are you a Star Trek fan or a Star Wars fan? But rarely does anybody ask me about Doctor Who. And that's a show that I grew up watching on PBS when I was young, and it got me hooked into sci-fi, and I think that's one of the reasons why I enjoy any type of sci-fi movie. So Doctor Who was a staple when I was growing up. Something that my wife introduced me to was yoga. And so we're regular practitioners of yoga. And I got to tell you, I am extremely thankful that she got me hooked, because being crammed up inside the descent module of the Soyuz capsule with your knees in your chest for hours on end is a lot easier after putting yourself through a few hours of torture doing yoga. I don't know if torture was the right word, but growing up in a small school, I got to play every sport. But the thing that really got me hooked and that was my passion was baseball. I was a pitcher, and so one of the things I did when I got to the Air Force Academy was walk on to the baseball team. And I played for a couple years there on the junior varsity team, and then got a chance to throw an inning at the varsity level. And then after that, they decided that my hobby was not going to go anywhere, and I got cut. So everybody has their individual tastes. When it comes to food, it's peanut butter and chocolate for me. That's an addiction I have. Who doesn't love a bowl of peanut butter and chocolate ice cream? The other thing that I really enjoy is crushed red pepper and garlic. If you put garlic on anything, it makes it taste better. So those are the things I crave when it comes to food.
Now, Haig ended up making it to the space station in the same spaceship with one of his astronaut classmates, Christina Cook. One of her favorite pastimes is mountain climbing, and Cook says the concentration and control that she learned in climbing helped her prepare to be an astronaut and to make the climb to space for her first mission to the International Space Station.
I first got involved in rock climbing actually in college. My college, North Carolina State University, offered rock climbing as a PE class. So it sounded really exciting, maybe a way to kind of get outside and have a little adventure. When I first got started, I liked more the physical challenge. That's what it was about. And as I kind of advanced in the hobby and got more technical, I found that I really liked other aspects of it, like the equipment, the gear, the physics of the system that you have to use, and also the partnership aspect of it. It's really like a team, because when you get into some of the higher levels of climbing and different types of more technical climbing, you really rely on your climbing partner. We train for spacewalks in a giant pool that's called the NBL, which stands for Neutral Buoyancy Lab. and it's a pool that's large enough to fit a full-scale mock-up of the International Space Station. So in that, we simulate everything like we would on a real AVA, including egressing out of the airlock, your safety tethers, and your local tethers that you would work when you're at a work site performing the job. So all of that is just very similar to the concepts of rock climbing. So during my astronaut interview, the most memorable question that I had from the interview committee came from Peggy Whitson, who, as you know, is a famous astronaut for having the longest time in space. She's done many, many spacewalks. She's a hero of mine. And she looked at me and she said, "When you rock climb, have you ever been scared?" And I felt like she was seeing right to my soul when she asked that question. And I feel like the answer to that question was absolutely, I have been scared. And that's when I really kind of found the fact that turning that fear that you might be having into focus is so important. And I think that's what she was drawing on when she asked that question. So that was a pretty profound moment in my selection process. I'm Christina Cook, and I'm an astronaut.
Cook, Haig, and Ovchinin and their 3 Expedition 59 crewmates are all officially in a sleep period all day long today for everybody to get cycled around to the right wake-sleep cycle. Tomorrow they'll start preparing for next week's spacewalk, and after that they'll be working a long agenda of laboratory experiments too. Over time they'll also get a chance to talk to people on the ground to share the experience. Some previous crew members have made an effort at that through fun instructional videos for students. And in this installment of this demonstration series, Scott Tingle demonstrates the orbit of spacecraft and offers the viewers a chance to participate.
Hello, my name is Scott Tingle, and I'm living and working on board the International Space Station. You know, I love my views from the cupola. It's our orbiting altitude of around 400 kilometers or 250 miles above the Earth's surface that gives us these unique perspectives. Let's explore how our ISS orbits work. Come on. First, I should explain, orbits are elliptical or oval in shape, with some being almost circular. Planets, comets, and moons have elliptical orbits. Spacecraft orbiting Earth, like the space station, are placed into a nearly circular orbit to keep a consistent altitude as they travel around the planet. Let's take a look at the Earth. It has a radius of 6,378 kilometers, and the station orbits about 400 kilometers above the surface at 8 kilometers per second. That's 17,500 miles per hour. See if you can use these values to calculate how far and how long we travel in one orbit around the Earth. All of this information and more activities related to orbits are available in the accompanying lesson plan at nasa.gov/STEM on station.
Answers coming in.
4, 3, 2, 1.
The answers to the questions, by the way, are approximately 42,600 kilometers and 90 minutes. And due to our altitude on orbit, we have our very unique and awesome view of the Earth. Thanks for exploring with me today. I'm going to send you back to Earth now so you can start your challenge on orbits. See you again soon.
Robotic technology that was originally developed for the International Space Station has found a way to help humans here on Earth in the operating room. The company that developed and built the space station's robotic arm has worked with a medical device manufacturer to create an automated robotic arm that tracks the movement of a surgeon's tools and helps to expedite brain and spinal surgeries.
The International Space Station is probably the most fantastic vehicle ever built
It's a one-of-a-kind laboratory orbiting about 250 miles above the Earth.
And we perform experiments on the International Space Station.
We can do science, we can do experiments, we can learn how to do things out of this world. And the result will help benefit the people on the ground.
So not only that, but we're also seeing benefits of how we actually assembled the space station.
So the International Space Station in its design was essentially designed like a Lego toy. Lots of big pieces that need to be put together. Some of these pieces are going to be about the size of a city bus.
We needed a way of manipulating or moving these big pieces and very precisely putting them together.
Canada worked with its contractor, which was MDA, and with that company came up with a design that was going to meet the needs of the International Space Station.
The solution to that was using a fairly large robotic arm. And that system ended up being Canadarm2. It could move around the space station, grab payloads, move them to where they needed to be so that the space station could be assembled.
You couldn't have built a vehicle like the International Space Station without a robotic system like this.
And that was when we started talking to Synaptive Medical.
Knowing that MDA has done this before in space, we thought it would be very easy for them to bring that experience and that technology into the neurosurgical area and help us with our medical robotics. We worked with MDA to create Drive. Drive is a robot mounted onto a base that holds a surgical camera that can be automatically positioned to any surgical instrument that's tracked by our system.
What this arm does, it follows you and it tracks you, so it speeds up efficiency.
Ultimately, using the Drive system allows the surgeon to have shorter surgical times, which means shorter recovery times for the patient, and ultimately that's better for the hospital and the patient.
But what the robot does for us is that it allows us to do it safer. You can do it better with less harm to the patient.
The software that runs on the Drive system is directly derived from the software that runs the Canadarm2 on the International Space Station.
Those robotics work with and alongside an astronaut to enhance what they do. So that connection is a very direct and real one.
Right now, it's probably the most used system that we could say is derived from the things we did on Space Station, and we're pretty proud of that.
And I've seen the arm before, we've seen it on the space station, but, I never put the two and two together that I'd have the same arm in the OR at some time, no.
I think everybody has this dream of how robotics are going to become more and more a part of everyday life. The things that we do with robotics on the space station is basically pushing those dreams forward. And we evolve the system, we gain the knowledge, we gain the experience, the expertise. So this is kind of the unexpected benefits that we get out of doing a program like the International Space Station.
The International Space Station has given us 20 years of scientific knowledge and a platform to test and perfect a whole new fleet of vehicles. The knowledge we continue to gain from this orbiting laboratory is vital to our future in space.
The International Space Station, a football field-sized, million-pound laboratory flying around planet Earth at 17,500 miles per hour. It's our home in low Earth orbit and the bridge to exploring the far reaches of our solar system. A place to learn what it takes to live, to work, to thrive in space. Thanks to space agencies representing more than a dozen countries around the world, it went from the drawing board to liftoff when the first piece flew into space in 1998. That kicked off over a decade of construction, hauling the station to orbit piece by piece on NASA's space shuttle and Russian rockets. And after the first crew arrived in November 2000, we started an unbroken streak of humans living and working in space. Building on the legacy of past outposts like Skylab and Mir, the International Space Station became the training ground for humanity's next great journeys. Learning how to live in space for extreme periods of time, building and perfecting the technologies necessary to travel to our neighbors in the solar system. It gave us a place right on our doorstep to prepare for the next giant leap into the unknown. And thanks to the station, a new era in outer space is unfolding. What was once the domain of only nations and governments is now populated by a growing space fleet from American industry. private spacecraft to fly cargo and crew members, new habitats and technologies for future space missions, and an open door for companies, research institutions, and even students around the world to do research in space that have never had the opportunity before. All laying the foundation for a robust economy in space. There have been thousands of experiments, hundreds of spacewalks, endless hours of challenges and successes, all done by humans hailing from countries around the globe. The International Space Station is what we can achieve as a planet when we come together to do the things that are hard. And the work isn't slowing down, because we're ready for the next giant leap, because we're ready to go farther, because what we do and learn along the way is for the benefit of all of humankind.
The International Space Station serves as a test bed for technologies that will be needed to support future flights of discovery beyond Earth orbit. And that includes the systems that will be needed to complete technical tasks and the systems that will be needed to make sure that the human explorers can survive in the harsh conditions of deep space.
The sweet smell of life support. Presented by Science at NASA. When NASA astronaut Kjell Lindgren blasted off from Kazakhstan in July of 2015 for his first expedition aboard the International Space Station, he had some lofty expectations.
I was eager to see Earth from space, and I couldn't wait to float in microgravity.
And he confessed.
I kind of expected the International Space Station to smell like a locker room.
After all, what would you expect? It's an airtight spaceship continuously occupied 24/7, 365 days a year by as many as half a dozen hard-working and exercising astronauts. Lindgren was in for a surprise, however.
The air in the space station actually smelled great. The filters and the life support system do a great job cleaning the air. There were no issues at all.
First contact with the space station's clean air reminded Lindgren, a flight surgeon, of the impressive technology underlying the station's life support system.
On the International Space Station, we're testing technologies that will allow us to live comfortably during long journeys into the solar system. Our life support systems provide a properly pressurized atmosphere with the right amount of oxygen. It scrubs carbon dioxide from the air, it keeps the temperature in a comfortable range, and provides fresh water and light and everything that we need for good hygiene.
Hence, the sweet smell of the air.
While I was on the International Space Station, I felt a lot like a bridge builder, helping to pave humanity's